I'm the director of the Wisconsin Initiative for Science Literacy. I'm, of course, professor of chemistry here. I'm very proud to tell you this is my 42nd year as a faculty member here, along with my colleague Hans Reich over here. And Tom Record is the third person who's been here for 42 years. Tom, are you here? We welcome you this afternoon to a very special presentation and a conversation by the editor-in-chief of Chemical and Engineering News, Rudy Baum. Rudy told me when I picked him up at the airport, this is the first time he's been in Madison. That surprised me. So we're not letting you go for a while, Rudy. We're going to keep you here so that you get to share, so we get to share with you the huge benefits that UW-Madison offers, not only in chemistry and all the chemical sciences, but to the culture of Wisconsin and to the culture of the nation, the culture of the world. Rudy's talk, as you know and see on the screen there, is entitled Sustainable Growth is an Oxymoron. I want to say a few things about Rudy briefly because you're in for a very special treat. Rudy's been editor of Chemical Engineering News and has been at CNE News for a long time, almost 30 years. He got his bachelor's degree in chemistry from Duke University, then enrolled at Georgetown University, and one day in his first year at Georgetown University, he answered an ad in the classified section of the local newspaper. An ad turned out to be from ACS, and joined ACS in the division, the education division. And the next thing he shared with me as we were driving from the airport is that when he was at ACS, in the education division, one day he saw an ad on a bulletin board, 3x5 card, in which they were looking for somebody to work in Chemical Engineering News, and he applied for that too and got the job. Rudy is a very thoughtful and provocative individual. He takes full advantage of the platform that he has helped shape as editor-in-chief of Chemical and Engineering News in addressing very important societal issues that are very much related to the role of science, in our case, the chemical sciences, in society. He is a person who I am very proud to be associated with him as president-elect of the American Chemical Society and as a longtime member, a 50-year member of ACS. I have thoroughly enjoyed his editorials and the other parts of CNE News that he has contributed to. I haven't always agreed with him, but that is part of the significant role that Rudy provides to all of us. And Rudy is a very, very thoughtful person, as I have said already. We all know, here's last week's issue of CNE News. Most of us now look at it electronically, but I still like this one because I can carry it around and show it. Here's last week's issue. I can't show you this week's issue because it's only on the web so far. So I want to show you very briefly a couple of slides that relate to why Rudy is in town here. He is, of course, to share with us what his title deals with. But I want to show you very briefly the theme that I have selected for the ACS during my presidential year 2012. Advancing chemistry, communicating chemistry. Advancing chemistry, we do that through research, through education, through innovation. And communicating chemistry, we do it in a variety of ways. In the scientific literature, we do it so well as we speak to each other and relate to each other. When it comes to communicating with non-specialists, we have a long way to go. And it is essential for us to consider the awesome responsibility that we have as members of a learned society, as members of a scientific society, as members of an educational society, to communicate our science to everyone in society. Well, everyone means there are different audiences that we have to deal with. And I'm very proud to tell you, very happy to tell you, that at UW-Madison this semester, along with Ron Seeley, the well-known science and environmental reporter for chemical engineering news for the Wisconsin State Journal, sorry Ron, we're offering a course to graduate students and postdocs that deal with the communication of science to the general public. So you've had a chance to look at this slide, and I'm going to change it very quickly, but before I do, I'd like to point out to you the all-important mission statement of ACS: to advance the broader chemistry enterprise and its practitioners for the benefit of Earth and its people. A very powerful statement. And its practitioners for the benefit of Earth and its people. I'd like everyone to think about this. In fact, my goal is that if I call you up at 3 o'clock in the morning, or somebody calls you at 3 o'clock in the morning and says to you, what is the mission of the ACS, you'd be able to say this without having to look it up. We should feel it in our bones as we continue our journey in advancing our knowledge and helping society appreciate what chemical sciences are all about. I also want to mention to you that Rudy is a very important member of the third initiative. I've appointed a working group that aims to help the public understand the science of climate change. And Rudy, along with 7 other people, a member of that working group. Actually, he's a consultant to the working group because he's an ACS employee, cannot be a full member of the working group, but he is as good as being a full member. So share this with you, and then the last thing I'd like to say before Rudy is to remind the graduate students in the audience and the mentors of the graduate students in the audience of the activity that the Wisconsin Initiative for Science Literacy has launched, and it is to invite all PhD chemistry candidates to include a chapter in your PhD thesis explaining the hard work and the discoveries that you made, explaining them to your mother, to your grandfather, to a member of the family, to our elected officials, to the program officers who supported the research that we do. So I call that to your attention. I also call your attention that if you do that, you get a $500 cash award. It's not only to the first 10, we're beyond the 10. So those of you in the audience would like to take advantage of that, please do so. And those of you in the audience who would like to see what the chapters look like, just go to our website, scifund.org, and you'll see the full listing of these chapters already there. So what I'd like to do now is present to you Rudy. So Rudy, would you come up here, please, because I have a couple of mementos for you from your visit to Madison. Here's a Sciences Fund button that would like you to have. And because of the thoughtfulness and the great service that you do to us, I would like to present you with this replica of the famous University of Wisconsin sifting and winnowing plaque, and I'll read it to you. It's a quotation. It goes like this: "Whatever may be the limitations which trammel inquiry elsewhere, we believe that the great State University of Wisconsin should ever encourage that continual and fearless sifting and winnowing by which alone the truth can be found." This is posted on the side wall of our Bascom Hall. And it really, those words exemplify to me, Rudy, what you do with Chemical Engineering News and what you do as a responsible member of the American Chemical Society. So this is for you, Rudy.
Thank you very much.
And ladies and gentlemen, Rudy. At the conclusion of the talk, you're all invited to a reception in the Shane Atrium to visit with Rudy and further have more conversation. So, Rudy Baum.
Thanks, Bassam. Thank you for that really lovely introduction. It's before I actually start my formal comments. Bassam mentioned that he doesn't always agree with what I write, and that's fine. It doesn't ever bother me that people don't agree with something that I've written in an editorial in CNN. One of the things that confounds me, though, is when people write letters saying that there shouldn't be anything in the magazine about policy issues or public policy, or we shouldn't be taking a position on a question of a controversial law or something. I find that just very astounding in this day and age when so many of the crucial issues facing us involve science and technology and have a huge component of science and technology. And it's part of the reason why we do not do as well as we should in addressing them is the fact that not enough scientists are really communicating with the public about, I think, scientific issues, and the public is not really very good at understanding them. So it is kind of interesting to me. But one of those issues is the topic of my talk tonight, sustainable growth is an oxymoron. I want to discuss today's sustainability from a number of perspectives, especially in the context of the topic of climate change, that I think is going to affect our lives significantly and dramatically in the coming years. I don't have a lot of slides, but as Bill McKibben observes in this book, Earth, Making Life on a Tough New Planet, many politicians and other policymakers talk about climate change as something that's going to happen in the future. They discuss global warming as something that's going to affect future generations unless we do something about it now. That's not really the case. Climate change is occurring right now. It's not a problem for our children and our grandchildren. It's a problem for us. I suspect that there are some people in this room who do not think that climate change is the greatest challenge facing humanity in the 21st century. And I suspect there are also some people here who don't think that human activity is responsible for the climate change that in fact is occurring. I hope there isn't anyone who doesn't think that climate change is happening. Numerous studies indicate that Earth's temperature has in fact increased by about 1 degree C since 1950. Climate change skeptics have challenged those studies on a whole variety of grounds. It's interesting, Richard Muller, a physics professor at UC Berkeley, and something of a climate change skeptic himself, founded the Berkeley Earth Surface Temperature Project to assess those questions. And interesting, when I was in O'Hare today, waiting for my connection to Madison, I got an email from one of my assistant managing editors, and Muller is actually presenting, he's not testifying before a hearing in Congress because he's actually presenting at a briefing because the Democrats don't control the House, of course, and so he can only be at a briefing, not a hearing. But he's actually presenting the results of the BEST, it's the Berkeley Earth Surface Temperature Project, the acronym is BEST, presenting that today at Congress. He has 4 papers that are now out for peer review, but the conclusion of their work, and they analyzed data from 39,000 unique stations around the world. And their conclusion is that all the previous studies that do show that 1 degree C increase in Earth's surface temperature are in fact accurate, and that the variety of criticisms like the heat island effect and the poor placement of the temperature stations in fact are not valid criticisms, that the temperature change is real. In fact, the terms climate change and global warming may be somewhat misleading. At a forum on international collaboration in science and technology, John Holdren, who is President Obama's science advisor, said, "Global warming is a dangerous misnomer. It suggests that the changes are uniform, primarily about temperature, gradual, and likely benign. None of these are true. What we should be calling the phenomenon," he told that forum, "is global climate disruption." The fact is, most people know that we're disrupting the climate. As is so often the case, Gary Trudeau is incomparable at capturing what's really going on. In this Sunday, and this, by the way, you read, it's a little screwy. It's down the left side and then down the right side. In this cartoon from a few weeks ago, NPR's All Things Being Equal host Mark Slackmeyer is introducing an honest businessman. He's saying, how does this work? Well, you can see what he's saying. The scientific case for global warming is overwhelming, and it grows daily. Only a moron would deny it. He opposes good policies because I care much more about my short-term economic interests than the future of the damn planet. Hello? The Wall Street Journal a few weeks ago ran an op-ed piece by a person named Robert Bryce entitled 5 Truths About Climate Change. Bryce is a senior fellow at the Manhattan Institute, which describes itself, and I'm quoting here from its website, as working to develop new ideas that foster greater economic choice and individual responsibility. I think it's fair to translate that into right-wing think tank. I've listed Bryce's 5 truths here. He concludes his essay, "It's time to move the debate past the dogmatic view that carbon dioxide is evil and toward a worldview that accepts the need for energy that is cheap, abundant, and reliable." As I wrote in an editorial in CNN recently, this isn't climate change denial, it's climate change indifference. This is the illustration that accompanied Bryce's op-ed piece. There is something deeply and disturbingly revealing about the attitude of Bryce, the Manhattan Institute, and the Wall Street Journal's editorial page toward the Earth in this illustration. The Earth is depicted here not as the planet that sustains us. It is instead a wailing baby crying out for its bottle of oil and coal to feed the smokestacks that sprout from its head, while hapless parents try to placate its hunger with windmills. The arrogance behind this illustration is almost incomprehensible to me. I'm sure many of you are familiar with this plot of the concentration of atmospheric CO2 at 3,000 meters on Mauna Loa. It's called the Keeling curve after Charles David Keeling, the man who made most of the measurements on here. He received his PhD in geochemistry in the early 1950s from Northwestern University. He began measuring CO2 in the mid-50s as a postdoc at Caltech in places like Big Sur and Pasadena. He took a job at the Scripps Institution of Oceanography in 1956 and started measuring CO2 on Mauna Loa, as well as a number of other places, including Antarctica, in 1958. He ran out of funding, actually, in the 60s for the places other than Mauna Loa, but he was actually able to keep the funding throughout his lifetime. He died a couple of years ago. This is a truly remarkable data set. To me, it is the antidote to the arrogance of the illustration I just showed you from the Wall Street Journal. The Keeling curve shows that the concentration of atmospheric CO2 is rising. This isn't, and it really shouldn't have been at the time, surprising. No one had measured it before, but given the amount of fossil fuel that was being burned, a simple mass balance analysis guarantees the observed increase over time. The only thing in doubt, actually, is the slope of the line, because they didn't understand then, and we still don't have a perfect understanding of the role of the oceans in absorbing the carbon dioxide that we're putting into the atmosphere. What's truly remarkable about this plot to me is it shows that the Earth breathes 1 breath per year. Each decrease in CO2 is an inhalation, each increase an exhalation. Keeling understood what he was seeing immediately. Because the majority of the Earth's landmass is in the northern hemisphere, there are more plants in the northern hemisphere than in the southern hemisphere. In the spring and summer, these plants are absorbing CO2 as they grow and produce leaves and get bigger. In the fall and winter, the leaves fall and decompose. So you have inhale, exhale, inhale, exhale. One of the most unnerving aspects of global climate change for the human psyche to absorb is that it drives home with absolute finality that the Earth is finite. I know that sounds obvious, but people have never behaved as if the Earth were finite. They have behaved as if Earth and its resources, the environment itself, were infinite and that human activity could have no discernible impact on it. The Keeling curve doesn't demonstrate that climate is changing. It simply provides the evidence that supports the most obvious mechanism to account for the global warming that has occurred. It does show, in two very concrete ways, that Earth's atmosphere is finite and can be impacted by the biosphere. Humans account for the increase, plants account for this periodicity. And by the way, there's no question that the increase is due to burning fossil fuels. The isotopic signature of the CO2 proves that definitively. If Earth is finite, then by definition, so is our capacity to produce and consume. Yet we live within a socioeconomic system that is predicated on endless growth. The rate of growth in population and economic activity went exponential about 200 years ago with the advent of the Industrial Revolution. We call it the Industrial Revolution, but it was really a revolution based on the extraction of fossil fuels from Earth and their use to power machines and eventually to generate electricity. Civilization as we know it depends entirely on burning fossilized sunshine cheaply, because that's what fossil fuels are. They're the fossils of dead plants and dinosaurs, but those flora and fauna were just the machines that converted hundreds of millions of years of sunshine into compounds buried in the earth waiting for us to extract them. We burned the fossil fuels on the cheap because we treated the atmosphere as a free dumping ground for the waste products of combustion, primarily CO2. We treated the atmosphere, in fact, as an open sewer, the same way for a very long time we treated our waterways. The insidious thing about CO2 is that it doesn't stink or make us sick the way water pollution and other forms of air pollution do. Eventually, humanity was going to hit a wall that told us that a system based on endless growth was not sustainable on a finite planet. What seemed obvious was that at some point, we were going to use up the Earth's reserves of fossil fuels. In the case of petroleum, some experts believe that we've already reached what's called peak oil, the point at which we've extracted half of all of the petroleum on Earth, and that supplies were inevitably going to decline. Whether or not we've actually reached peak oil or not, we've certainly reached the peak of oil that's reasonably easy to extract from the Earth. If that weren't the case, why are we drilling in 5,000 feet of water through 13,000 more feet of rock as we were in the Gulf of Mexico in the Macondo field that resulted in the BP oil well disaster? Why, if we haven't, why are we contemplating drilling in the Arctic Ocean with all the incredible risks that go along with that? Or contemplating drilling in 2 miles of water through 15,000 feet of rock off the coast of Brazil? Why are we contemplating building a pipeline from Alberta to the Gulf Coast of the United States to bring heavy, sour crude to be refined in the Gulf Coast refineries? It turns out that it doesn't look like the availability of fossil fuels is going to be the wall that puts a limit to growth on a finite planet. Climate change, global warming, global climate disruption, call it what you will, is going to be the wall that's going to be that wall. There are enough fossil fuel resources left on Earth for us to keep the economic engines that have powered 200 years of exponential growth going for another 100 to 200 years. But the climate isn't going to let us do that. But an aside, there's enough fossil fuels for us to continue in business as usual mode for some time. But at what cost? Even leaving climate change aside. We have no idea what the long-term environmental impact of the BP oil spill is. We're blasting the tops off of mountains in West Virginia to get at the coal that's buried under them, and in the process destroying hundreds of miles of pristine streams and despoiling hundreds of square miles of landscape essentially forever. How much of our environment are we willing to degrade to satisfy our addiction to fossil fuels? The fact is that eventually we're going to have to learn how to live off the sun in real time. Fossil fuels, and it's not going to be easy. Fossil fuels aren't just fossilized sunshine, they're concentrated fossilized sunshine. McKibben claims in Earth that 1 barrel of oil, and I think this is right, yields as much energy as 25,000 hours of human manual labor, more than a decade of human labor per barrel. The average American uses 25 barrels per year, which, he writes, is like finding 300 years of free labor annually. To live off the sun in real time, we're going to have to make some changes. We're going to have to slow down, and we're going to have to get a lot smarter. Slowing down will involve making the wrenching transition from an economic system to an economic system that is not predicated on growth. I don't know what that system looks like. In my mind, it's something that I call a high-tech subsistence economy, in which consumption is no longer the sine qua non of success. And we're going to have to make the transition to living off the sun in real time. We're not going to make that transition a year or two, or even a decade or two. In the meantime, we're going to have to go through a transition where we still burn fossil fuels, but hopefully burn them more cleanly, during a time where we probably build more nuclear power plants, and learn how to deal with the waste that's left over afterwards, and during which time we adapt to a changed and disrupted climate. As Holdren pointed out at that policy forum, humanity has 3 options in the face of climate change: mitigation, adaptation, and suffering. We're already doing some of each, he said. What's up for grabs is the ultimate mix of the 3. Mitigation can't work alone because the climate is already changing and is going to continue to change regardless of what we do starting tomorrow. We will have to adapt to an altered climate. We're already adapting, whether we acknowledge it or not. The new flood walls surrounding New Orleans are, in fact, an adaptation to climate change. And unless humans are able to limit global warming to no more than 2 degrees C on average, which at this point is very much in question, the suffering that humanity faces is going to be severe. What role does chemistry and the chemistry enterprise play in this? We don't call it the central science without good reason. And in the world of a changing, disrupted climate and an evolving economic system, chemistry will take on an even more important role than it has in today's society and economy. Green chemistry and green engineering will obviously play an important role in creating more sustainable manufacturing practices. It's already having an impact. Last year, I interviewed Paul Anastas, who is the Deputy Administrator at EPA for the Office of R&D. And he is also one of the fathers of green chemistry and engineering. And he said to me, "My vision for the future of the Office of R&D includes a recognition that the goal of sustainability is our true north, that scientific and technological innovation is essential to the success of our mission, that we need to couple our excellence in problem assessment with an equal excellence in solving problems, and that we must act with a sense of urgency." In our interview, however, Paul also referred to a speech that EPA Administrator Lisa Jackson had given, in which she said, "It's time to put to rest the notion that economic growth and environmental protection are incompatible. It's time to finally dismiss this false choice." That's a comforting notion. But it's really not one that's any longer true. Sustainable economic growth, as in the title of my talk, is an oxymoron. We live on a finite planet. We have to learn how to have a healthy economy that doesn't depend on endless growth. And it should go without saying that a critical component of such a society is one with a stable global population. Of course, green chemistry and engineering don't address the energy challenge that is at the heart of climate change. Learning to live off the sun in real time is a challenge that must be addressed by chemistry and the chemistry enterprise. We're doing it now, but not nearly enough is being done, and it's not being done with the sense of urgency that is required. We need to develop over the next few decades mechanisms for the large-scale conversion of sunlight into electricity and liquid fuels needed to power our society. We need batteries and other new technologies to store massive amounts of electrical energy generated by variable sources such as solar and wind power. These are all challenges that fall under the category of mitigation of climate change. They are mechanisms to head off the worst aspects of the worst case scenarios of climate change. Chemistry and related disciplines will also be called on to contribute to the inevitable adaptation that humans will have to adopt in the face of a changing climate. We will need crops that tolerate higher temperatures and survive on less water. We will need new herbicides and insecticides to deal with pests that are migrating in a changing climate. We will need new pharmaceuticals. Chemistry, in fact, is the science that will be called on to preserve really any semblance of the quality of life that we've come to depend on and accept as our due. Are we up to this task? Certainly, chemists around the world are making important contributions on all of these fronts. As the editor of CNEN, I visit chemistry departments and I'm continually impressed, sometimes amazed, with the vigor and enthusiasm that people like you are bringing to their work. I have talked for many years about chemistry both as a core discipline and as an enabling science. And it is as an enabling science that chemistry is going to be called on to contribute to the mitigation and adaptation of climate change that's going to be happening in the coming years. I see chemists working increasingly in multidisciplinary teams with biologists, physicists, material scientists, physicians, engineers, and others in focused research that is leading to new drugs, new materials, new catalysts, and new processes to meet the ultimate goal of a truly sustainable economy. On the other hand, climate scientists like Jim Hansen and Stephen Schneider have been warning about the growing threat of global warming for at least 25 years. And to tell you the truth, we've done almost nothing to change the disastrous course we're on in terms of the use of fossil fuels. Chemical scientists are optimistic about what they can invent and create to help with the mitigation of and adaptation to climate change, but not nearly enough is being done. There is no political will to solve this problem, in this country especially, because solving it requires sacrifice, and almost no one, especially here in the United States, is willing to ask humans to sacrifice. This is the cover of a book, a novel, by James Howard Kunstler that I learned of by reading Bill McKibben's Earth. It's a dystopian fable of a world some numbers of years from now, a world that has drastically changed climate and a complete breakdown in the social order. It is a world in which the machine age has ended and major forms of energy are once again human and animal muscle power. It is literally a world made by hand. Is this a likely scenario for our future? Probably not. But it's not out of the question. James Lovelock, the originator of the Gaia hypothesis, has a much more dire view of where the Earth is headed in the face of climate change than the one that Kunstler has. Lovelock predicted some 2 or 3 years ago that by 2100 there would be 500 million people on Earth. As you know, there are about 7 billion. We just crossed that threshold a couple of weeks ago, and that would be a cataclysm of just unimaginable proportions, and yet Lovelock has been right about a number of things. And if you've read Jared Diamond's book, Collapse, he shows very clearly how complex societies can implode almost overnight, especially in the face of rapid environmental changes. Excuse me. I'm not as pessimistic about humanity's future as Kunstler. Humans are amazingly adaptable and amazingly creative. But cheap energy in the form of fossil fuels burned without any concern for their impact on climate has allowed humans, and let's be frank about this, allowed humans to be stupid about the way we've developed our civilization. We have no choice but to get smarter, and we have to do it very quickly. I think it's up to scientists to lead this charge, and to lead it in two ways. One, by doing the science that they do, by making the kinds of advances that the world needs to address this incredibly important question. But at least as importantly as vocal advocates for changing the course, for changing the path that we're on. Not enough people with the credibility of scientists have taken up this cause with the passion it deserves. We're talking about the future of the Earth. And because scientists know that this problem is real and serious, and can explain that the arguments of those who deny that it is real and serious are specious. You know, we haven't always been known as scientists. I learned one day driving home, listening to NPR's Real Science Friday, that scientist is a word with a definite origin. It was coined in 1834 by Cambridge University historian and philosopher William Ewell. The older term for people pursuing scientific activities was natural philosopher. And in Ewell's view, that term was too wide and too lofty. Perhaps natural philosopher is too wide and too lofty a term to describe people who do science. However, I think we may have given up something when we abandoned natural philosopher for scientist. It isolated us to some extent, allowed us to retreat into pursuing scientific inquiry for its own sake, and in doing so, cut science off from humanities and scientists off to some extent from their responsibilities as citizens. I don't know whether anything we do can change the course that we're on, but I think we have to try. If scientists are the ones who know that global climate change will be a human tragedy of as yet undefined proportions, and we do nothing about it, what does that say about us? And why should society continue to support us? What, in fact, is the role of the scientist-citizen? And I'm not going to try and answer that, but it's something that I hope all of you will give some thought to. I'm not saying that we should go back to calling ourselves natural philosophers. I am saying that scientists, especially chemists, who are among the most practical of scientists, must become much more involved in this most important challenge and issue facing us today. Thank you very much.